Welcome, everyone. You're in the right place to see industry strategies for proven data sharing options with your presenters, Tiffany Carone and Sean Tolodziecki. The floor is yours.
Great. Thank you, Jana. Hello, everyone, and thanks for taking the time out to join us today. My name is Tiffany Carone, and for the next 30 minutes, we will be discussing what data integration is and why it's important. We'll discuss the challenges of siloed information, some of the data sharing options available, and also strategies that we've seen that are successful in the current business climate. Now, before I introduce our presenter, as Jana mentioned, please feel free to ask questions in the chat or Q&A section, and we'll try to address what we can at the end of the presentation. So without further ado, I'd like to introduce Sean Tolodziecki, our Business Development Manager for our software development team. Sean, the floor is yours.
Thank you, Tiffany. I hope everyone's doing well today. Before we jump in, let's do a little bit of housekeeping. Just make sure, Tiffany, if you can confirm you're hearing me okay.
I can. Thank you.
All right. And we should have one slide up here on the screen. That's the presenter view. I think we are all set. So let's jump right in and kind of set some expectations. I want to talk a little bit about what we are going to cover today and really what we're not going to cover. We're going to talk a little bit, very high level, about what data integration is, some of the business challenges that are caused and or faced with data integration, and also kind of an overview of how the concept of data integration has evolved over the past 20 or so years. It means a lot of different things to a lot of different people and have some of the same common lineage, and I want to talk about that a little bit, what industries are impacted. I do have a couple of examples, as I will probably mention several times throughout the course of this conversation. It means something different to everybody, just depending on how your business works and what you're dealing with directly. But there are some common practices, and there are some best practices as we talk about for strategies to get that done. And as both ladies have mentioned, here at the end of the conversation, we'll have some questions as you guys would like to ask them. So what is this not intended to be? That's probably just as important as what to expect. This is not, by any stretch of the imagination, supposed to be a comprehensive list of everything that you could ever face and every benefit that you could ever get. As I mentioned, it's all very unique and it's all very specific to each case, but we'll just talk about the top-level ones. It's not intended to be product-specific implementations. This is not a product demonstration or a product sales pitch of any kind. I will mention a new solution that IMAGINiT has brought to the market in the past 9 months or so, but that's just at a very high level. As I mentioned, I want to keep this high level so it's beneficial for everybody. We don't get too far in the weeds for manufacturing clients or AEC clients or anything like that. And it's certainly not supposed to be a how-to either. We've got a team of consultants and professionals that can help you work through that and address your specific needs as we get into that project. So let's jump right in. What is data integration? Simply speaking, it's exchanging data between systems. It's taking the information that we generate on a daily basis, and everybody sitting in our own cube, pegging away at a keyboard. We're all doing the same thing, working with information, just different forms, different views of it. A CAD file is the same thing as a sales order in a lot of ways. It's a different way of looking at it. There's a lot of common information in there. As you can see from my cool little graphic here, all of our colleagues are working together to put the same puzzle together. We're all working with the same information and passing that along. We're trying to take advantage of that, kind of leverage what the colleague that's gone before us has already done so we don't have to do it over again. So we're taking that information, we're collecting it, and we're passing it downstream. Who can benefit from data integration? Or, again, simply speaking, everybody. Each industry has a specific way in which they can benefit, or maybe a specific type of data that they're working with. But there's solutions on the table now that fit for every industry you can think of. Whether it be manufacturing, medical, civil, AEC, anywhere down the line, there's always something out there that we can do. Now, traditionally, this is kind of thought of in the manufacturing space. of being able to capture your items and your bills of material and things like that. And that's certainly where a lot of the traction was gained early on. You saw a lot of manufacturing clients taking advantage of opportunities to pull bills of material out of AutoCAD in the old days, so to speak. Still do that now, by the way, but ultimately pulling that information out and using it. But their successes and really, quite honestly, a lot of their pains and failures have kind of painted a roadmap for how we go about addressing it across the board now. And you've got the AEC clients taking advantage of it with being able to pull data from, say, Revit models or, again, AutoCAD drawings if they're still using AutoCAD. Being able to get that information out and use it downstream. Populating specifications. It's a big task that a lot of us have to do is go through and review a requirement and review a design and type that monster Word document or monster PDF that represents a specification for a big project. So very similar. You're able to do a lot of the same things. We're also linking to GIS info a lot of times, being able to connect to maps and all that kind of good stuff. And then facilities assets management, facility management for assets, grabbing what's there and managing it, tracking it through its entire life cycle, being able to capture the data up front, put it into a management system like Archibus or some of the other solutions out there, and be able to track that through its lifetime, handle repairs and get to schematics and things like that. All of that falls into the data integration bucket, and if done properly, we can all benefit from it. We can all leverage that data across the board. So why is it important? Bottom line, we're all here, I hate to say it, but it all comes down to the same thing. We're all here for the same reason, that's money. Whether it be profitability of a particular project or value that we can drive into our individual employers, whatever the case may be, business revolves around time, and that time directly is related to money. Human factors, we can eliminate a lot of that. We can eliminate the error, the incomplete information, the failures to act, which means you don't do something that needed to be done. We can drive efficiencies by having events trigger things. When something completes on one side, it automatically does the other. Get rid of that dreaded typing, making that happen in a controlled way that we'll talk about a little bit. But ultimately, it all comes down to delivering a better product in a more efficient way, which translates directly into dollars. So what are some of the benefits that we can see? Reduce cost of doing business. How do we reduce cost of doing business through data integration alone? You're still going through the same processes. You're still doing the same things. So how is that going to reduce our time and errors? Well, if you guys all remember, there's been plenty of times where we've received some sort of hard copy or an email or something of that nature from somebody upstream from us, whether it's at the early stage of a salesperson sending in the requirements for an order, or as we get further along, the guys out on the shop floor taking a bill of material and looking through it and going through and pulling their data. If we can eliminate the time that's spent re-entering that information, let's say I've got a large assembly. I've got a large machine or even a big building that's got a lot of different components in it that's going to fall on a takeoff in the AEC world. If I've got to type all that over again, if I've got to take that printout or take that design and go through and review it and essentially redline what I've entered and keep going until I get it all done, that takes a tremendous amount of time. It certainly isn't that impactful if it's a couple of lines that have a couple of items, but how often does that really happen? It's normally sometimes in the neighborhood of hundreds, if not thousands, of rows of information you have to type in on a daily basis to move that down. All of that information can be captured and passed down. So now, instead of me sitting at my desk for 8 hours plugging away at the keyboard, entering all this information in the next Excel sheet that the person down the line from me is going to have to turn around and do again, I capture it from the first time it's entered, either from the sales rep, as I mentioned, entering it in, or the results of a designer or engineer entering it into the design. We're capturing that information, and we're able to eliminate the fat finger errors, so to speak, where you don't type it in, you hit a 0 instead of an O, or whatever the case may be, just invalid keys, whatever the case is. you're able to eliminate those errors. And once it's entered once, it's always going to be correct downstream, passing it over. Computers may do a lot of things that frustrate us on a daily basis, but one thing they don't do typically is make mistakes. Once you work out the code, once you have it validated and you have the processes working, it's going to turn to it over and over and over again, and it's going to do what takes us sometimes hours to do. It's going to do in a matter of seconds, if not less. You can also apply validation to that data. Let's say, for example, I'm entering something and it's got to be a certain category, or I'm entering furniture on an order and I've put it in as an accessory or something. We can validate that information. When you enter a part number, we can grab the description, we can grab the weight, we can grab all the other information that needs to go with that. It's going to be, again, unique in each situation, but we can grab all of that and we can make sure that it's correct. And we can also apply business rules to that. When I have this, I need to make sure I have that. When I have, one of the things that we've done a lot of work in is the playground industry. I started my career in that playground industry. If you have a deck, for example, that a slide needs to come off of, if I drop in a deck, I know I've got to have 4 posts that support that deck. Generating that complete bill of material, adding the information to that design can be done automatically now. Now I'm not that guy sitting there with a plan in front of me, typing in the deck part number, hitting enter, going to the next line, typing in those post part numbers, and entering all the nuts and bolts and things of that nature. We can go even further than that. We can validate that what we've got is a valid combination. So if I know that I have to support 5,000 pounds on something and I've got the grade 1 bar on it, and it's probably not going to support that. I can correct that, or at least bring the attention to the user, show them that they need to address this particular problem. So we're able to reduce the time of entering it, and we're also able to apply business logic to it and apply rules to it so we can drive it forward and enhance it. What does that ultimately result in? It results in faster response times to our clients. Now, instead of having to sit and wait 2 weeks for a response on a quote, it can sometimes be instantaneous. They've gone through and they've entered their information. We've let the system run, with the system process, and then we can get that bid out more quickly. And anytime we can respond to our clients more quickly, as long as that's a quality response, then we're able to enhance our position in getting that project or winning that order. We're able to focus on the important areas. That's why I mentioned a moment ago that it's a quality response. If I'm spending less time in my design cycle typing the same information over again, or going back and double checking it, or manually applying some of these rules that I've talked about with some of the business rules that can be applied, if I'm spending less time doing that, I'm able to spend more time designing and spend more time looking at ways that either I can enhance the delivery of the product and make their solution better, maybe drive some cost out of it for them by leveraging components a different way, or even upselling. They now have the ability to respond back with a better design. We're able to spend more time doing what we really want to be doing and what our clients are paying us for, our expertise in a given area. We also include that improve the quality of that response. So when it goes back, there's not typos in places. There's not data that's misaligned or anything like that. It all lines up and it all fits what we were looking for. We can have that consistent presentation back to our clients. We can have that quality data captured and presented in a way that really makes us shine as the service provider that they want to select. So let's talk a little bit about the genealogy of integration. And I know it's using funny words for data in this case, but it really did start, as I mentioned a few moments ago, in the manufacturing space, I don't know, probably early 90s. We started trying to extract attributes out of AutoCAD and push it into our ERP systems, or in the architectural world, which I was in at the time. We were trying to take designs out of our CAD packages and push them into takeoffs and things like that, be able to see how much a particular project is going to cost. But it began very tabular in nature. And you had very much like everything was Excel data. It was columns of information just went on and on for days. And that migrated over to design information. We started seeing, like I said, block counts and things like that in AutoCAD. Started taking that a bit further, being able to get a rudimentary bill of material out of AutoCAD. Inventor took that the next step further and gave us a quote-unquote true bill of material in the design based on the assembly and things that we entered there. Then Revit came onto the surface and took what AutoCAD architecture was doing, which was the block attributes and counts and things like that, and took it another step further and really started giving us a BIM-aware design tool. So now we've got a lot more information in there. And as you guys know, there's a ton of information in a Revit model that certainly goes well beyond what a particular symbol looks like or what a floor plan is made up of. There's all sorts of data in there that drive to a specification. All that information is in the model. It's great for scheduling, but how about we use it somewhere else? How about we take that data and push into that specification document that I mentioned before? Right now, until we've tied that together and we've put solutions in place to drive that information, it's great to have it, but what are we really able to do with it outside of the design environment? If we don't pull that data out and leverage it, there's not a lot of value there. So we started seeing that evolve and started seeing other tools pulling that data out. We started seeing Vault and started managing that data. Again, this kind of started on the manufacturing world, but it's expanded since then. We're doing Vault client implementations across all industries, and we're all getting the benefit of being able to pull that information out. And Vault starts to introduce some other things that we'll talk about in a few minutes. And recently, with the move to cloud-based solutions, Fusion Lifecycle and the BIM 360 products have started opening up even more reason and benefit from pulling this data out and reusing it across the board. We're able to collaborate a lot more. We're able to share that information with people outside of our walls and be able to host that with vendors and guys out on the floor, guys out on the job site, walking around maybe with augmented reality glasses, looking at a building, trying to find where a particular problem is and getting the schematic of the unit that goes with that. All of this type of information falls into where data integration is going. Started, like I said, very early on with very tabular data, very invoice and quote-looking information, and gone to real live, usable data that enhances what we're able to do every day. So as the data has matured, our tools and our ways of working with them have matured as well. I mentioned trying to extract block attributes early on in AutoCAD days. I can remember back in the early parts of my career, I wrote a solution for the playground company I was working for. That was really what it did. It went through and counted the blocks and got some properties, some other attributes off of those blocks for each design that we went through. And that text file that was used to pull that out and bring it into an Access 2.0 database really made a huge impact. And we went from hours and hours of going through taking these things off and entering those bills of materials and importing them in a matter of minutes. So it really made a huge impact back then. Then we started looking, all right, we're now working with things that have a database that we can access. And early on, there was a push to reach from CAD directly to the database that was driving our MRP or ERP systems. And although that was possible, that was very dangerous. There was a lot of failures that took place, and quite honestly, a lot of negative connotation around integrations were started to be perceived because of that. What happens behind the scenes, I'm not trying to get too deep in the weeds, but if you have an item in CAD, that might be housed in 5 or 6 different tables in a database. It might be in the item master table and in the warehouse table and this pricing table, all these other places. If you don't get that right, if you don't get the data entered in all of those tables, you essentially corrupted the data. So although database direct made things a lot more efficient, eliminated the user aspect of it, it also introduced some fear, I guess you could say, some potential risk to corrupting your data and really causing more problems than you were solving. Well, as we continued to evolve and as data and really, quite honestly, the industry and consumers in general continued to evolve, those software manufacturers realized, hey, I've got to be able to work with other people. I can't live in my own little world anymore. As Tiffany mentioned earlier, they can't have their own little silo. and act like that there's nothing out there in the world that we have to talk to anymore. So they started giving us APIs, or application programming interfaces. What that does for us is it gives us a common gateway. So now from inside AutoCAD or inside Revit, I can push a button and I can collect all the data that I've got that I want to pass over in my CAD package. I can push that over to, say, for example, in the Revit world, a takeoff package. And that takeoff package recognizes it. It understands the structure of the tables that it has. It understands how to put that information in all the appropriate tables and handles that for us. So there's application vendors recognize that, hey, I've got to be able to support getting this data into my system properly. I can have this crazy complex scheme for my data structure. That's fine, as long as I give an easy method to get that information in there, and that's what that API did for us. So then we started seeing web services, and software as a service began to become more prominent, and it started to really be seen and required in a lot of different places. You got your Salesforces and all these other things out there that just about demand that you work with them in their way. So what is a web service? A web service is effectively an API for an online application. It serves very much the same purpose as the APIs that I mentioned before for your ERP systems and your takeoff packages that are installed locally, but it's out in the cloud and it's handling those interactions. It's allowing us to capture data from one system and pass it over to data in another system. Well, web services have gotten so prominent and they're showing so much success that the APIs that were originally available in a lot of these local packages, on-premise packages, have actually been migrated over to web services there as well. So it's really the preferred method today. So when I'm looking at a project, first thing I'm going to say is, okay, what data do I need to grab? All right, I understand that. What am I taking it to? Okay, I'm taking it to this solution. What is my way to get it there? What does that particular package or that particular vendor offer? And probably 7 times out of 10 today, there's a web service out there that says, okay, Pat, tell me what your item is, and I will set it up for you and get it created in my package so you can now work with it and carry it forward through the workflow that I support. So if I've got a drawing that I've done in Inventor, I can pass that item and bill of material data over to my ERP package and turn that into an order right then. And that flows downhill out into the shop floor for production through the bill of material, all that kind of good stuff. So I mentioned earlier that IMAGINiT had recently started offering a new package to kind of help with this. That package is IMAGINiT Pulse. What Pulse is it's a middleware that essentially sits out on the cloud and listens for things to be said to it or for things to happen. It's essentially a collection of web services that is bidirectional. It's hearing things in one ear and spitting it out through the other side. So if I've got Vault, for example, that I want to connect to my ERP system, Pulse is sitting in the middle saying, okay, Vault, tell me what you need to do or what's going on and passing your information. And then whatever my destination application is, whether it's an ERP system or a takeoff system or Google Maps, for example, we've done some crazy stuff like that. I can now translate that data and pass it over. Pulse sits in the middle. So the benefit to you with that is you have one connection for each system that you're wanting to connect. So instead of having to build a solution that's dedicated for a combination, so if I've got my Vault and a particular ERP system, you can build one solution that only addresses that. Then if you change ERP systems, you got to go rebuild it. Well, now you've got that Vault piece stays the same. You just change the endpoint that Pulse has there. And I just completely wasted this slide by talking through the whole thing without the pretty graphics. But essentially, what I just talked about is what we're saying here. You're creating endpoints on each end of Pulse, listens for the activity on both sides, and passes it through. So let's talk just a minute about a couple of examples. I'm going to use the typical manufacturing example because that's the one that everybody's heard before, everybody can relate to. It's kind of where everything started. So I'm off drawing. I'm doing my thing in AutoCAD or Inventor or wherever, and I'm creating that design. I'm essentially creating data. I'm generating the need for, in my little picture down there, I've got 2 tires and 2 ring arms and swing arms and all that kind of good stuff. I'm generating the relationship of that information. I'm creating a need for it. So now I've got part numbers and quantities. I don't really care about anything else. At that point, I don't much care about what the description is or weight or any of that kind of stuff. I'm saying this is my design. Here's a visual representation of it. It's made up of this item this many times and so on and so forth. So when I'm finished my design, I can now take that information and check it in the vault. Now I've got it in vault, and I'm able to manage that cycle. So I go through the approval workflows, or I go through the life cycle changes. You don't have to use the change engine inside of Vault, change management engine inside of Vault in order to do this. You can just use regular life cycles as well. It's an event. Anything that triggers it allows us to pass this data. So I bring it into Vault, check it in. Vault pulls in all of my data. It knows what my design is. I go through and I approve it, and now it's approved and it's ready to go out to the rest of the company. So once that approval has been done, Vault will recognize it, and we can collect that information. We can validate it. We can make sure everything's there. We can make sure that there wasn't anything out there where maybe an item was unknown or anything like that. Now I've got a complete list on the Vault side of what my items are and what my bill of material is. I can reach out to the ERP world and say, okay, do you know what all of these items are? Do you understand them? Yes, I understand all of those items. Or no, I don't understand all those items. Create the ones that I don't know. So I pass that information over from Vault to create all these new items that I have. So now I've got the ERP system recognizing all of the items that I have a demand for. Now we push them over, and we push them over in not only just creating the items, we also structure them. We create the bills of material for them as well. So we've now created any missing items or any new items in our ERP system, and we've now structured everything together, and we've got our bills of material. And if our ERP system was using the change process inside of it as well, we can actually trigger that release as well. So we've done projects where we've communicated with an ERP system without change being used on the ERP world, and we've done some where we had a very complex change process. So in order to start a design, we had to create a change. And we had to go through and validate that all of the items that were on my change weren't on any other change. So we were able to walk through all that. Things that were taking sometimes days to go through and validate, because you could have a large assembly, can now be done instantly. And we get instant feedback displaying to our user, okay, here's some things that are out of sync with what I expected, go deal with it. And you're able to focus on those problem areas. If there's no problem areas, it's automatic, and that data is transferred over by default. And we've released it. Now it's available to be used in our manufacturing facility. So let's look at an example that we've done in the facilities management world. This particular client needed to have a plan to deal with disaster. I'm actually from the Carolinas, so we've recently had a hurricane come through, as you guys probably know. So this gets home fresh. This particular client was probably impacted by some of those issues that came from Hurricane Florence coming ashore. So what they needed to have was alternate buildings that were set up for a certain number of key personnel to be able to go to and continue business as usual. They would continue to function. So what they had was disaster recovery plans. And they would go through and they would generate a disaster recovery plan in another system that would ultimately push out an Excel file. That Excel file essentially represented a demand of what was needed. It gave us a list of, I need this many workstations assigned to this department, and they have these characteristics. Some would have internet connectivity, some would just have local network, some would have phones, some would have recorded phones. They also had some need for relationships between those. So this department couldn't be beside that department, things like that. So what we did was we took that data out of that export from that spreadsheet and we pulled it into a design solution. So it would go through and lay out some of the relationships between those cubes, those departments that can be beside one another, knowing which lines could be recorded and things like that. It populated all that data into a floor plan. Now, we did have to have the user come back and QC it and make sure that it was what we needed, and we modified it a little bit manually. But ultimately, it took a tremendous amount of the data interpretation and data entry aspect of it. For each cube, we would have to enter all the properties for that cube. We would have an ID, and it would have an assignment to departments, all that kind of stuff would all have to be typed in. Now we're doing all that automatically. When a cube comes in, gets populated, it pulls that data in, and it's got the full detail associated with that space. And we're able to push that recovery plan out to the IT group. So they now have a script, so to speak, that they know when they have an outage for 1 to 3 days, they have to go set the workspaces up like this. When that outage is going to be day 4 to day 10, maybe that changes because it grows as the outage becomes longer. The demand on the number of users that have to be in this given space changes. So we have people shuffling around quite a bit in this scenario. But all of this is done through design iteration and linking data from the different requirement sheets to the physical layouts to the IT recovery script, so to speak, so they know where to go through and assign that. They're able to distribute that sheet to 5 or 6 different IT resources, and they're able to make sure that everybody's up and running. And there is no leading a plan, figuring out what needs to be here or there. Saved a tremendous amount of time in this case. So what does it take to implement? As I mentioned, everybody's situation is unique. Everybody has different information that they're looking to pass, maybe at different times. Yeah, there's a lot of common elements to it. There's a lot of same data. We're dealing with items, we're dealing with part numbers, we're dealing with that kind of stuff. But each time something is unique. So we take a take-aim approach, which we've done for many, many years now and has proven extremely successful. It gives us a very structured methodology to go through and evaluate what needs to be done. Step 1 is going to be to determine at a high level what the needs are and put in place a rough order of magnitude. It's really just a fancy way of saying an estimate that gives our clients an idea of what kind of timeline they're looking at and what kind of budget they're looking at. Once we move into that, we've actually started doing what we call an agile development process. We used to do fixed bid proposals where we put it out there and we had to deal with the dreaded change orders and all that kind of stuff for anything that got missed along the way or anything that changed along the way. So we'll often see changes as we go. So this agile approach breaks everything down into much smaller segments. And it gives our clients the ability to control at a much more granular level where their effort and where their dollars are going. So we develop the sprint requirements at the beginning of each sprint. We go through, put them in place, we implement them, and we test them, and we validate them. We're seeing projects of this nature range from a week or maybe even less. I mean, if you've got a simple extraction you're needing to do, we can knock that out pretty quickly, up to many, many months. I mentioned the client that we worked with that had to validate changes and do a lot of user notification and that sort of thing. That was a several-month project. It had a lot of business rules in it, a lot of complexity, but the same approach applies to both that week-long project and that several-month project. We go through and we break it down to a much more manageable level. We see a much, much higher degree of success. In the cases where we're talking about a solution like Pulse, you start seeing a little bit different elements come into the pricing. Because it's a software as a service, we're hosting it for you. You're going to have a base platform cost, and then you're going to have costs for those endpoints. And each one of those is going to have some degree of upfront cost. Your base platform is just pretty stable. It's about $5,000 a year. And then the endpoint is going to depend on what you're doing and where you're going. And then you're going to see year-over-year costs after that. You're typically going to have, if you've got a custom endpoint, you're going to have a little bit more upfront cost than you would year-over-year. But really, it's made it a much more manageable upfront investment and long-term investments you can plan on accordingly. Those type situations or those type platforms don't fit every scenario, but as we're engaging, as we're talking about it, we're certainly looking at the best way to do that, whether to do a completely custom solution just for you or to do it through a platform such as Pulse. Some of the key takeaways from our conversation today. As you guys saw, as we talked through it, there's a potential to drastically reduce time. As we're taking that just pure overhead time out of it, we're doing two things. We're either making ourselves the opportunity to be more profitable, or we're making ourselves the opportunity to lower our costs, so therefore lower the price for our customer therefore make us more competitive in the marketplace and maybe eliminate that competitor that's still doing all of this stuff manually. It makes our presentation to the client much more appealing. We're able to eliminate all the human errors. Well, not all of them. You're never going to get all the human error out, but we're able to get the mundane data entry type errors. We can catch a lot of the design issues as well through some of the validation that we've talked about, but really where your huge impact is just taking that time out of having to go through and re-enter that and eliminating the traditional typing errors that you often see. Solutions have matured over the years. So if you've always heard that data integration is a great concept, but it doesn't really work in reality because of this, that, or the other thing, that's truly not the case anymore. It's kind of become the requirement and become the standard to have to work together. Many years ago, every solution vendor kind of protected their own backyard, so to speak. They didn't want anybody touching it, anybody working with their solution because they had to support that. And they didn't know where anybody would be coming from, so they were avoiding that risk by keeping it locked. Well, that's not the case anymore. We as consumers and we as a marketplace have gotten to the point where we demand, hey, if I type that once, I don't ever want to type it again. And even in the simplest nature, we type a password into Chrome or Edge or any of those explorers, we expect it to be maintained going forward. I don't ever want to type it again. Until I need to go change it, don't make me type it again. That's really the same thing. That mentality has driven the market to the point that they all have to be working together. And once we get systems talking to one another, we're able to manage the process that they're going through, and we're able to report on it. We can see where things are going. We can see what data is moving from what position to what position. We can see where errors come up. We can see where things get hung up and go after it and deal with it. This all leads to a lower cost of doing business and improved response times. And that's really what we all want to see. We want to be able to get what we need to get done at a lower cost. And if we can drive error out of that, we don't have to ship product secondary. We don't have to go back and catch things on the shop floor. Anytime we can drive cost out of doing business, it's a win across the board. And then along with that, as that time comes out, the cost comes out, as we've talked about many times, but it also allows us to respond more quickly. So now instead of it taking 2 weeks to get a quote back to a client or get an order out onto the shop floor, we can do that in a matter of hours. So that takes us to our question and answer session. Jana?
One moment while I end today's recording.